Hi you guys, I'm going to show you today how to graph scatter plots through a graphing calculator using Desmos, and I'm also going to show you how to get that line of best fit. So we're going to go to desmos.com first, and you're going to go ahead and hit that graphing calculator button. And in order to graph a scatter plot, we need to actually give it some points. So you're going to go to that add button, hit the table, and you need to use your keyboard, which is in that bottom left-hand corner. So that's your keyboard button. If you have a number key over on your actual keyboard on your computer, then you should be fine anyways. So you're going to add the table like we said before, and then we are going to go ahead and enter in. Let's just, for this example, let's press 1, hit enter, and then 2, enter, 3, 4. It actually started repeating it for me because it kind of knew what I was doing. 6. But you can go ahead and enter those in. And now we're just going to enter some data points. So I'm going to say 9, 5, 7, let's say 6, 4, and 10. Okay, so my points were over here. I couldn't really see them. So I'm going to drag the screen over here so I can actually see them now. So now our table has actually plotted those points. So great, we did our scatter plot. You guys would go ahead and enter in your x values, your y values of the example I give you. For this purpose, we're using these numbers. So the next thing is to have this actually calculate our linear regression line for us. So you're going to go ahead and get your keyboard, make sure that you are on the numbers. You could do A, B, C to get to other ones. I'll show you how to do that. So we do have y1, you're going to put 1. And then instead of using an equal sign, the key point here, you guys, is you actually have to use the tilde sign. And then so if you go to the table where it has the letters, it's actually right down here below the B and the N. So right there, that's a little tilde sign. And then we're going to use our x1 right here. So we have to type in, we want our equation, remember, y equals mx plus b. So m, and then x1 is the graph that I'm going to be going for my x values. So x1. And then we're going to go into plus b. So it actually graphed our linear regression line for us. However, I want you guys to actually write out the equation so I know that you guys know what the linear regression line is. So remember that your b, your perimeter right here, your b perimeter and your m as your slope and then your b as your y-intercept, that's going to be part of your equation. So for this purpose, let's round to the 100th place. So 0.0, since that's an 8 before after that 2, this is now going to go to a 3, x, and then plus 6.73. And it should graph it directly over it. You guys can change the color on it to make sure it went directly over it. And that's your actual linear regression line. Yay, so we did it. So those were the 3 steps: creating a table, entering your data, making sure it's the y1, our first equation, with the little tilde sign, and then mx1 plus b because you're using this table. And then you're also going to actually finally write the actual equation. The other thing I wanted to talk to you guys about was the r right here. So you see with the r equals 0.02307, and that is called our correlation coefficient. So because this is a positive line, it is increasing, even though it's very slowly, it's increasing still. So it is a positive correlation. However, this number 0.02 is definitely not close to -1 and 1. So this is actually a very weak correlation. So I wanted to show you guys a little bit more on what the actual correlations are. So I'm going to exit out of this and I will bring you guys to my actual presentation. So for linear regression and graphically and correlation coefficients, I want you guys to kind of draw images that are very similar to this. So positive correlation means that we have a ton of dots kind of going in the upward direction. And negative correlation would mean that we have our dots are kind of going in the motion of going down. We'd have no correlation, or this could also be called a weak correlation, where our dots are kind of all over the place. So go ahead and draw kind of mini pictures. Make sure you label them appropriately. Then once you guys have that, so our correlation coefficients, they're always going to be between -1 and 1. You can never go over 1 or less than -1. So what I want to show you guys, these are kind of dots. This is our positive, still going to be a positive correlation. And in this case, we would call it a perfect correlation because it has hit all the points. And this is a very strong association or correlation. Then if we look over here to the right, the R close to 1 point plus 1, it's still a positive 1, so it's a positive correlation. However, if I were to draw a line, I wouldn't be able to hit all the points, but it still is going to be a strong association. Then the reason why this turned negative is because now we have a negative correlation going down. It is a strong correlation, but again, I would not be able to hit all the points. So this is still a strong correlation. It's just not a perfect one like that first top left example. The other part are close to 0, or it's weak or no, there's no association. So the closer the numbers are, that R value is closer to 0, then it's going to be the weaker correlation. Closer to positive 1 and closer to negative 1, the stronger the correlation. So here's some images of what I wanted to show you guys. So see how this R equals 0.7? This is definitely closer than this 0.3. And so that means that this left one, this one has a much stronger correlation than this second example. R equaling 0, we can see our dots are all scattered all over. So this is a weak correlation or doesn't have a correlation. And then all of a sudden our numbers turn to negative down here. Again, negative 0.7 is still closer to negative 1, which means that this correlation is much stronger than this negative 0.3. Again, the dots are more spread out, so it's a weaker correlation. And then our R equaling 0 is the same as the above. All right, you guys, so I hope that helps, and I hope that you guys get to see what's going on. And if you have any questions, I'll